Hello everyone. In this video, let's try to solve a problem that is related to divisibility by 7. Here comes the question. Find the number of positive integers n such that n is less than 10 to the 6th power 1 million. N only contains the digits 9, 1, and 0, and n is divisible by 7. When people see this problem, the first question they may ask is, how to judge if one number is divisible by 7? Or what's the divisibility rule of 7? Typically, we're familiar with the divisibility rules of 2, 3, 4, 5, 6, 8, 9, 10, and sometimes 11. But the divisibility rule of 7 is less known. There are actually a few divisibility rules of 7. The one I'm going to use is more useful in dealing with large numbers. Here's the rule. Assume n can be expressed as a, b, c, d, e, f, which is the number with 6 or less digits. Then n is divisible by 7 is equivalent to a, b, c, and d, e, f. Those two 3-digit numbers are congruent modulo 7. For example, we know that the number 1, 2, 3, and 11, they're congruent modulo 7. Then, from here, I can conclude that the number 1, 2, 3, 0, 1, 1 is divisible by 7, and the number 1, 1, 1, 2, 3 is also divisible by 7. The proof of this rule is based on the fact that the number 1001 is divisible by 7. In detail, number ABCDEF can be written as 1000 times ABC plus DEF, and 1000 equals 1001 minus 1. And this expression can be further written as 1001 times ABC minus the difference between ABC and DEF. So, ABCDEF is divisible by 7 is equivalent to ABCDEF is congruent with 0 modulo 7, and which is also equivalent to 1001 times ABC minus the difference between ABC minus DEF, congruent with 0 modulo 7. Since 1001 is divisible by 7, then this expression can be further equivalent to ABC minus DEF, congruent with 0 modulo 7, and eventually ABC and DEF are congruent modulo 7. Knowing this fact, my task now is to choose two numbers ABC and DEF. Those two numbers, first, they should be congruent modulo 7. In other words, when divided by 7, they should have the same remainder. And second, when those two numbers combine together to form a new number ABCDEF, this new number should contain and only contain 3 digits 9, 1, and 0. And each of the 3 numbers must appear at least once. So, knowing my task, the first step, I'm going to write down all 1, 2, 3 digit numbers that contain 9, 1, or 0. And I will categorize those numbers based on their remainders divided by 7. And this is the table after I finish this step. For example, in column 1, there are four numbers 000, 091, 119, 910, and all those four numbers, they have the same remainder 0 divided by 7, and those goes to the second, third, and all those different columns. Second step, for each possible values on that table, I will set it to be ABC. Then I need to count the number of possible values of DEF that meets the requirement. There are two requirements here. First, DEF could only be chosen from the same category of ABC because they need to share the same remainder divided by 7. Of course, DEF could be equal to ABC. Second, after ABC and DEF combined together, each of the three numbers 910 should appear in the new number at least once. And please note that the leading zeros do not count. For example, if ABC is 000, then the possible value of DEF could only be 910. That means for 000, the count is 1. If ABC is 091, then possible values of DEF could be 000, 091, and 910. That means for 091, the count will be 3. I'm going to repeat this process for all the remaining numbers, and this is a table. So finally, the number of possible n is the sum of all those counts. And in this table, I found 5 times 1, 7 times of 2, 11 times of 3, and 4 times of 4. And the final possible n equals 1 times 5 plus 2 times 7 plus 3 times 11 plus 4 times 4, which is 68. And this problem gets resolved. Thank you.